finishing this problem that we started on?
We can finish this one.
Or at least almost finish it.
Okay.
We did A. Hold on one second. We figured out that the interval of convergence was from -1 to 1.
Right.
Now, to do B, if you evaluate this function at 1/2 by the first 3 terms of this series, you get that. In other words, if you plug in 1/2 for x,
Okay.
those are the first 3 terms. So if I plug in 1/2 for x, I get 19/96. Show that this approximation differs from f of 1/2 by less than 1/100th. Well, what they're basically saying is if I carried this all the way out to infinity,
Right.
I would have an answer that would be less than that.
Okay.
From 1996. Now, there are some rather advanced calculus techniques for figuring out the remainder called Lagrange. Have you had that?
I think we learned it.
I do not ever remember seeing a question on the AP exam regarding Lagrange remainders. We don't want to go into it anyway.
Okay.
Here's what I'm going to suggest is how we prove this. We can figure out what the first 5 terms are. And this error gets less and less the more terms you add. But you got to be careful. This is an alternating series. So, in other words, if I added only 1 term, that one right there, well, I might not be within that 100th.
Right.
But every 2 terms you add gets more accurate. So if I want to improve the accuracy of the answer, I'm going to add 2 more terms.
Okay.
2 more terms. You always want to add them in pairs.
Okay.
Because one makes it go up a little bit, the other makes it go down a little bit less, the next one goes up a little bit less, the next one goes down a little bit less. So if you don't do it in pairs, then it's possible that you would get further away from the exact answer. So I would try that, okay? And
Okay.
I would just plug in 1/2 into the first 5 terms, see what you get as a decimal, and see if it's within 1/100th of that. And I would leave it at that. If there's more to it than that, then too bad. This is one of the hardest questions that we've seen.
Right.
However, let's look at part C. Because C you are going to come across again. And C is not necessarily intuitively obvious. First of all, let's come up with the first 3 non-zero terms of f prime of x. So you're basically differentiating that. Whoops,
Okay.
that's a minus sign. Because notice that after you differentiate it, this first term goes to 0. So if you're looking
Right.
for the first 3 non-zero terms, you got to look at the first 4 terms of that sequence. So
Right.
differentiate each one of those. What do you get?
2x.
Hold on. We'll start with the 1/2. That goes to 0.
Right.
Minus
2x over 4
keep going.
plus 4x to the third over 6 minus 6x to the fifth over 12.
Yeah, and that can be, some of those can be simplified. You'll notice that that's a half, that's 2/3, that's a half. Okay, so those are the first 3 that's 0. So the first 3 non-zero terms are those terms there.
Okay.
Now, the general term is what tends to be a little tricky, only because you're not used to differentiating something like that. It appears to have 2 variables. But when you're differentiating it, you should treat n as if it is a constant.
Okay.
Therefore, what would the derivative of x to the n be?
nx minus n minus 1.
Okay. That's all you do. Treat n like it's a number.
Okay.
Which is important because otherwise this would be really tough to differentiate.
Right.
Okay, so if n is a number, notice that if I were to differentiate this, I would get n times minus 1 to the n minus 1.
Right.
That alternates between minus 1 and 1, and then minus 1 and 1, and minus 1 and 1. So does this. So the derivative of minus 1 to the n, we don't have to worry about that so much.
Okay.
Now let's talk about the derivative of the rest of it. This really isn't as hard as it looks. First step.
Bring the 2n down.
So it's 2n times x to what?
To the 2n minus 1.
Like that, not in parentheses. And then the bottom is a number, so it just stays there.
Right.
You don't have to use any quotient rule or anything like that.
Okay.
So that's the general term. Now I can simplify it a little bit. It looks like I can divide top and bottom by 2. So that gives me nx to the 2n minus 1 all over n plus 1. So that would be
Right.
a simplified answer.
Okay.
So when you take the derivative of a series, you either take the derivative of each term or you take the derivative of the general term. That's the general term right there. So I'm just going to take the derivative of that, treating n like it was a constant.
Okay.
Okay? Now, there is something interesting that happens. Notice that the interval of convergence on the first one was minus 1 to 1.
Right.
Turns out that the derivative has the same interval of convergence. So does the integral. although not exactly. In other words, the one thing that can be different when you take the derivative or the integral is whether you have a parentheses or a bracket. If I take the derivative of this function, it's possible that it can turn into that.
Okay.
Or if I take the integral, it might turn into this.
Right.
Any of the four possible combinations. And you don't know which. Now, we didn't really talk about the endpoints on this first one. It's a kind of a confusing subject, and I think our time can be better spent. Incidentally, when is your next test, or when is your final test?
I don't know what our final test is, but our next quiz will be probably next Friday.
Guess what my question is how long do we have to work? How many weeks before you?
About 2.
Okay. That being the case, I think it makes much more sense for us to work with these kind of problems right here.
Okay.
This is what you're going to see on the test, mostly. It's problems like this, as opposed to problems like the last one.
Right.
How are we going to do number 1?
Number 1 would be integration by parts. Or no. Partial fraction decomposition.
Okay. So let's work with the function. Let's decompose it. We'll let you do the whole thing.
Okay, so a over x minus 1 plus b over x plus 6, and then equals a times x plus 6, or x plus 4 equals that. A times x plus 6 plus b times x minus 1. So then that would mean...
And the reason that's equal to x plus 4 is because the denominators are identical. Both
Right.
denominators are x minus 1 times x plus 6.
Okay.
Okay, so keep going.
So then we're going to substitute in a number that gets rid of a or b. So let's do -6. So that gets rid of a, and then it'll be b times...
Start with the left.
-7.
Always go left to right.
Okay, so then -6 plus 4 is -2 equals b times -7. So b equals 2/7.
Good.
And then do the same thing, get rid of b with 1. So then 5 equals a times 6. So then a equals 5.
We're letting x equal 1, right?
Correct.
So what do we get?
5/6. Or 5 equals a times 6.
No, x is 1.
Oh, a times 7. So 5/7.
Now, that's actually not an okay answer because we have to integrate it.
Right.
What should we do to integrate the first one on the left? In other words, let's rewrite it so that we don't have a fraction in the numerator.
Okay. I'm not too great on doing that. I usually just leave it.
Well, let me just show you how to do it.
Okay.
Okay. And then we're integrating those so those fractions can come out.
Right.
So I can take that 5/7 out, and I can take that 2/7 out.
Okay.
So what's the integral of this? That's 5/7 times the integral of 1 over x plus 1 dx.
That would be ln of x plus 1.
Okay, so ln of x plus 1, still got the 5/7 in front of it.
Right.
I don't have to make that an exponent, but I could if there was some advantage of doing it. And over here we've got 2/7 times ln of x plus 6. So I'm going to leave it just like that.
Yeah, usually what I've seen on our tests is that they either leave it like that or they multiply what is being.
Well, notice there's a lot I can do to this. I can condense it rather easily.
Right.
In other words, if I condense this, this is the same thing as natural log of x plus 1 to the 5/7 times natural log, or excuse me, not times natural log, times x plus 6
to 2/7.
2/7. In other words, that single expression is condensed. And then I can't do much with it beyond that.
Right.
One is x plus 1, one is x plus 6. They're both fractional exponents. Can't even multiply them together.
Right.
So, I guess I could multiply those together and then multiply them by 10/49 front. But I don't know how far you need to take it. If it's a multiple choice, you'll know how far to take it.
Right.
But if it's you have to give an answer, then kind of is up to your teacher as to whether you can leave it like that on the lower right or whether you have to take it all the way down as far as you can.
Okay.
Okay. Now, I don't see number 2 being any different.
No.
Number 3 looks like it might be a little different.
Okay.
First thing I need to do to number 3.
Factor the denominator.
Okay, what's it factor?
I am not sure.
Well, notice you're looking at a cubic. What's the greatest common factor?
Sorry, my phone is ringing. The factor would be, we factor out an x.
Okay.
The x squared.
Yeah, and that leaves x squared plus x minus 2, which can be factored how? Or factor that part of it.
Right. So that would be, what would multiply to multiply to 2 and then add to positive 1?
Subtract to 1. Because of
So, right. So it'll be 2 times negative 1.
It's x and x. You know the
So it's x
signs
plus
have
2
to be
x.
opposite. And the middle sign has to rule, so the 2 has to go with the middle sign.
Right.
All right. Now, that's really the problem they meant to give us.
Right. They want to give us A, B, and C.
Okay, so it's A over X plus B over X plus 2 plus C over X minus 1. Now, let's see what goes on the right side.
C.
If you were adding those 3 fractions together, you would have this common denominator. What goes on the top left? A times what?
A times X plus 2.
Keep going.
And plus B times...
Hold on, no. By keep going, I meant there's also an X minus 1 there. Notice that if I put the common denominator under that, you have that.
Right.
That's what you want to make sure of always, that you have not changed it.
Okay.
Okay? Now I don't need to write that common denominator because I know it's the same, and we're going to end up equating all of this to the number 1.
Right.
But it's plus B times what?
X times X minus 1.
And plus C times
X times X plus 2.
Okay. Now, all of that has to be equal to the numerator on the other side. So let's see if we can do it the typical way. Let's see, we can get rid of C by letting X equal 0. Well, that gets rid of B and C. So that has to be a good idea.
Okay.
What's A equal to?
When we're letting X equal 0.
Uh-huh.
So A would be equal to 2 times negative 1. So that would be negative 2. So negative 1/2.
Good. Now, can we get rid of B?
Well, we could get rid of A and B at the same time.
Yeah. So letting A equal to 1 has to be a good idea also.
Right. So when we get rid of A and B with X equals 1, C would equal
that.
Right. So 1 times 3. So C times 3 equals 1. So it'd be 1/3 would equal C.
Huh?
So now we need to get B.
Yeah, once you know A and C, what's an easier way to solve for B?
Plug in negative 2.
This has it all, yeah. It's not common that you can do this technique always.
Right.
Sometimes you have to use a more sophisticated technique. But in this case, if I happen to let X equal minus 2, I get rid of the A term and the C term. So I have 1 equals B times minus 2 times minus 3. So B equals 1/6.
Right.
So, what is my answer? Hold on, let me erase some of this, but not all of it. You still got to do the integration. In other words, we've done the hard part. Normally, the integration part's relatively easy.
Right.
So the integral of all of that is what?
The integral of all of that would be negative 1/2 over x plus the integral.
Hold on. What's the integral of 1 over x?
Ln x.
That's what that becomes.
Okay. So then plus 1/3 or 1/6 ln x plus 2 plus 1/3 ln x minus 1.
Good. And that should be sufficient as an answer.
Right.
You
So I
could
have
do
to
a lot
sign off.
of that, but go ahead.
I have to sign off and go to baseball practice.
Okay. Good. Glad you mentioned it. John, I'll talk to you next time. Have a good one.
Yeah, you too. Thank you so much.
Bye-bye.